gonna share my screen. Okay. Okay. Okay, it works. Perfect. And then, all right, so we can start, I guess. So this is, again, we're in the same section, section 1.7. We are doing the composition of functions. This is section 1.7. And okay, so let me first remind you just the idea, so this is, again, this is composition of functions. Okay, I think we had, so the idea is the following. So we had an example of the fractions. So let me do it again. So that's, so we are saying, so we had like, let's say f of x is, 8x over 1 minus x, right? And then I think our g of x was like, I think 3 over x or something. Yeah, I think so. Yeah, 3 over x. Okay, so we have two different functions, f and g, right? And then we want to find or compute f of composed with g of x, right? So we want to compute f of g of x, right? So you see, here's your f. This is your f, right? Now in your f, we have an x in the top here, and x in the denominator, right? And the idea is to replace those x's with g of x. So now if you want to compute this f of g of x, then instead of x, we're going to have a g of x. So that would be like, so that is equal to 8. And then instead of x, we're going to have g of x. So that's 8 times g of x over, and then we have 1 minus x, and instead of x again, we're going to have g of x. So this is 1 minus g of x. Okay. Now, so what's g of x? Here's my g of x. So my g of x is 3 over x. So let's just compute this thing here. So f of g of x would be like 8 times, so it's supposed to be 8 times g of x, but g of x is 3 over x, right? That's the top. Now the denominator, we have 1 minus, and then g of x, which is supposed to be 3 over x. Okay. Now, Rakim, you're asking, is this the same as a substitution? Yes, it's the same as a substitution. Yeah, so we substitute x by g of x. Yes, yeah, absolutely. Now, so now we have like multiplication and subtraction of fractions. So just you need to be careful with those operations. Like in the top, we have 8 times 3 over x. So this is like a whole number times a fraction. So it's a good idea, guys. Whenever I have like a fraction and the whole numbers, it's a good idea to convert the whole numbers into fractions. Like this 8 here, it's a whole number, but I can write it like a fraction. So it's all you have to do is to divide by 1. So that's like 8 over 1, right? And there's this 1 here in the denominator. I can write like 1 over 1, right? So it's whenever we have like a fractions, it's better to convert your whole numbers into fractions. Now, because now, so now we can do like in the top, you have multiplication of fractions, and all you have to do is to multiply.
Wait, Professor. So 8 with next to the blue, there's a parentheses next to that, right?
Yeah.
8 and g of x. Okay.
Yeah, 8 times. This is 8 times. This is like 8 times g of x. Yeah, absolutely. And then, yeah, so then you have to multiply this 8 over 1 by 3 over x. And so you multiply straight across. So this is like, you know, this is 8 times this 3 here, and this 1 here times this x. So that'll be 24. That's 8 times 3, and then in the denominator in the bottom, it's 1 times x, which is x, right? So that's 24 over x. So that's the top. Now, the denominator, it's a subtraction. And so how do we do the subtraction of fractions? You need to get the common denominator. So what do I mean by common denominator? Like here, the denominator is 1, right? So you have to multiply here the top and the bottom by 1. Here, the denominator is x. You see this x in here in the denominator. So I have to multiply the top and the bottom here by x. So it's like x times 1, x over x times 1, it's x, minus 3 times 1 is 3, of course, and x times 1 is x, of course. Okay, so now once you have a common denominator, so then you can subtract the tops, and you need to keep the same denominator, the common denominator. So they'll be equal to, so in the top we have this 24 over x over, now I have to subtract the top, so that's x minus 3, and keep the same denominator, the common denominator, which is x. So this one here, you have to keep it, right? So you keep this common denominator. Now, okay, now I am done with the subtraction. Now I have a division, I have a division of two fractions. And the way you divide fractions is you flip the one in the bottom. So it's, 24 over x times, and then you flip this one here. So it's 24 over x times x over x minus 3. And so now I have multiplication of fractions. So just multiply straight across. Here and here. So that will be 24 times x over x times x minus 3. Okay, now because you have an x in the top and x in the bottom, so then they cancel out. So this x in here and x in here, they cancel out. So it's just, now it's just 24. And they cancel out because it's we need to have like multiplication in the top and in the bottom. I mean, if you have like 24 plus x over x times x minus 3, then you cannot cancel out the x's. So you need multiplication in the top and in the bottom if you want to cancel out something in the top and in the bottom, right? So that's really important. So now it's 24 over x minus 3. And of course, now there's nothing you can do. I mean, that will be the final answer. Is there any question, guys? Again, don't be shy. Feel free to.
Wait, Professor, is it going to be for when we write down the answer in the homework?
Yeah.
We just put 24 over x minus 3. It wouldn't be f of anything?
No. You just write down 24 over x minus 3.
Okay.
Of course, you have to show all the work, but
no, yeah, obviously.
Yeah. But that's the final answer, 24 over x minus 3. Mm-hmm.
Because yesterday, when we did the example to compute, it was at the end it was g of f x equals the answer. That's why I'm asking if we need to have something.
Yeah, I mean, it's just another way to present the answer. Okay, I see what you're saying. Yes, so you can just I mean, I mean, this is.
I just wanted to know if it was necessary because
no, it's not. It's
yesterday's
not.
example.
No,
okay.
No, it's not necessary. I mean, you can just stop here. That's the final answer. You're done. Or of course, I mean, another better. I mean, if you, if you prefer, and I mean, a better way to present the final answer is to write like f composed with g is equal to 24 over x minus 3, etc. But I mean, yeah, it's not necessary. Mm-hmm. Is there any other question, guys? Okay, so let's do another an exercise with the fractions. Because I know sometimes it's not obvious all these operations on fractions. Okay, so here's an exercise, similar exercise. So let's say my f. So my f of x is, let's say it's 2 minus x over x plus 4, right? And let's say g of x, it's, let's say it's 1 here. So g of x is 1 over, let's say, x minus 1. Okay, so what you need to do, guys, please compute or find f composed with the g of x, right? And g composed with f of x. Okay. So I'm here, guys. If you have any trouble, any question, any problem, just let me know. So again, guys, just if you are late or something. So next Monday, it's a holiday. It's Columbus Day, so no classes next Monday, and I'm gonna meet as usual Wednesday after. So Samira, you're asking for F composed with G. Actually, I don't know the final answer. I'm not sure. I mean, I have to solve the problem because I don't. I mean, I don't have. I don't know the answer. But for me, it sounds correct. So your answer sounds correct, but I'm not sure. Yeah, I mean, I have to, yeah, I have to solve the problem. Uh, so you have to compute F composed with G and then G composed with F. Just make sure, guys, you do the right. I mean, at each step you do the right thing. I mean, the right operation. Just be careful, subtraction, fractions, division of fractions. Again, my advice is if you have like whole numbers, just make, I mean, divide by one, so then there will be a fraction. Okay, so it's make everything look like a fraction. Oh, okay, Muhammad. Yeah. So yeah. So then I guess it's correct. I guess it's the right answer. For G over F, I think I can guess the answer. G over F minus X plus 1. Is there. Uh, um, well, yeah, it sounds, yeah, I think it's correct, Samira. Yes, I think so. Uh, yeah. Um, but yeah. But again, I have to solve the problem because I don't know the right. I mean, I'm not sure about the right answer. Um, are you done with the exercise, guys? Anyone need more time? Okay, I guess you're done. Well, at least I can start with the first one. Number one, the F composed with G. right? So yeah, so let's do the first one. So f composed of the g of x. So we said it's f of g of x. And as I said, probably it's a good idea to write down your f first. So f is supposed to be like 2 minus x over x plus 4. So yeah, Kwame, I'm not sure about the final answer. So yeah. Um, um, okay, so you see there's an x in here and an x here in the bottom. So I'm gonna replace both by g of x. So it's like 2 minus, g of x, and then divided by, again, g of x plus 4. So here's a plus 4, right? So let's do it. So it's 2 minus g of x, which is 1 over x minus 1, divided by g of x, which is 1 over x minus 1, again, plus 4. Right? So again, as I said, it's a good idea to make this whole number 2 as a fraction. So I'm going to divide by 1, and the same, this 4 here divided by 1, right? So now everything looked like a fraction. Now I can do subtraction. In the top I have 2 over 1 minus 1 over x minus 1. So it's, we need the common denominator. Common denominator here, it's x minus 1. So I have to multiply here by x minus 1 times x minus 1. Here, the denominator is 1, so I multiply here by 1, multiply here by 1. In the bottom, the denominator here is 1, so I have to multiply here by 1. And denominator here is x minus 1, so I multiply here like like you cross multiply, right? So we multiply here by x minus 1 and x minus 1, right? So it's like, so we're going to have 2 times x minus 1 over x minus 1 minus 1 times 1 is 1 over x minus 1 times 1. The whole thing divided by, and then we have 1 over x minus 1 plus 4 times, so we need the parentheses, guys. It's x minus 1, and there's an x minus 1 in the bottom, right? Okay, so um, Um, so now I have a subtraction in the top and I have addition of fractions in the bottom. So, and I have my common denominator. So in the top, I'm going to subtract the top. So it's like 2x minus 1 minus 1 over my common denominator, which is x minus 1. And in the bottom, I have the addition. So I'm going to add the tops, which is 1 plus 4 times the x minus 1. And the denominator is x minus 1. Right? So now let's just simplify. The top here is 2x. Here if you distribute, so this is like 2 times x minus 2 times 1. So it's 2x minus 2 minus 1 over x minus 1 over, and here you have 4 times x and then 4 times 1. So it's like 1 plus 4x minus 4 over x minus 1. All right, so now I can, simplify the top. So that's equal to, here it's 2x minus 2 minus 1. So you see here, this is minus 2 minus 1. So it's going to be minus 3. So 2x minus 3 over x minus 1. And in the denominator, I have this 1 here minus 4. So it's negative 3. So it's 4x minus 3. So it's 4x minus 3 over x minus 1. So it's, so this is now division of fractions. So it's 2x minus 3 over x minus 1. And then you flip, times, and then you flip this one, the bottom. You flip it. Right, so it's now, x minus 1 over 4x minus 3. All right. So this is multiplication, right? So you multiply straight across. So this is like, so that's equal to, 2x minus 3 times my x minus 1. And in the denominator, we have x minus 1 times the 4x minus 3. And of course, now we have x minus 1 in the top, x minus 1 in the bottom. They cancel out. So final answer would be 2x minus 3 over 4x minus 3. Right? I think, Samira and Muhammad, I think you got yes, you got the right answer, guys. So yes, your answer is correct. That's very good. Any question, guys, about how I got this 2x minus? So that's the final answer, of course. Any question,
Wait,
guys? Yes.
Professor,
Mm-hmm.
you just leave the -3 there, right? It doesn't get crossed out.
No, that's the thing. Okay, that's actually a very good point. So you can cancel out when you have multiplication in the top and in the bottom. So
that's the only time?
Yeah, that's the only case. Yeah, you see here, I have multiplication here in the bottom and the top and the bottom. That's why I can cancel out the x minus 1. So here,
Okay.
there's 3 here. I mean, even if this is 3 in the bottom and the top, but I cannot cancel out the 3 because it's not multiplication there. It's subtraction. So you need multiplication in the top and in the bottom, right? So even if it's like times 3 here, let's say it's multiplication here, that's still I cannot cancel out because it's a subtraction in the denominator. All right. So you need the multiplication in the top, both in the top and in the denominator. Right.
Okay, got it.
Mm-hmm. So this is sorry. So this is minus. Oops. There's minus. So it's minus. Mm-hmm. Okay, any other question, guys? All right, so let's do now number the G composed with f, right? So now the G composed with f of x. So my first function is G, right? So I'm gonna write down what's G. So G is 1 over x minus 1. So my G is 1 over x minus 1. So I have this x here in G. So I need to replace that x with f, right? So it's gonna be like 1 over, and now it's gonna be f. So f of x, and then there's a minus 1. Right? So then G composed with f of x, it's 1 over, so f. So what's f? Oops, sorry. So f is, where is it? F is 2 minus x, x plus 4. So 2 minus x, x plus 4. So 2 minus x, x plus 4. That's my f. And then there's this minus 1, right? This is minus 1 here. So here's my minus 1. Right. Now, as I said, it's a good idea to make everything look like a fraction. So like I have 1 in the top. I can just divide it by 1 here, and I can divide here by 1, right? So now everything will look like a fraction. Okay, now I'm good to go. So, well, in the top, it's just 1. I mean, in the bottom, I have subtraction, so we have to subtract. So we need the common denominator. So I need to multiply here by x plus 4 and here by x plus 4 because my denominator here is x plus 4, and I have 1 here as a denominator. All you have to do is multiply by 1 here at the top and the bottom. So you're going to have, so that will be equal. So you have like 1 in the top, and then you have like 2 minus x times 1, x plus 4 times 1. So it's going to be just the same thing. And then minus 1 times x plus 4. So that's x plus 4 in the top and in the bottom. Okay, so now I got same denominator, common denominator. So that's 1 over 1 over. And then I can subtract, because now I have this common denominator, I can subtract the numerators, right? I can subtract the numerator. So it's 2 minus x minus, and then you're gonna need a parenthesis, guys. So this is really important. So we're gonna need parentheses. So x plus 4, and then the whole thing divided by, of course, by x plus 4. So then, so that will be equal to, so we're gonna have 1 over 1 in the top, and then in the bottom I have like 2 minus x, so I'm gonna distribute the sign, so it's minus x minus plus 4, that will be negative 4 over the x plus 4. Okay, so it's still 1 over 1 in the top, and in the bottom we're gonna have 2 minus 4, so it's a negative 2, minus x, so it's minus 2x over x plus 4. Okay. You're saying, Muhammad, you got minus 2x plus 6. The plus 6, I guess it's because, well, I think you have a problem with the sign. I'm pretty sure from my computations. So my f 2 minus x plus 4. Yeah, I think 2 minus 4, it's not plus 6. Yeah, the parentheses, they are really important. Yeah, you see here these parentheses here. Yeah, that's important. Yeah. Yeah. Now, so now we have division of fractions. So I'm gonna flip this one here, right? So it's like 1 over 1 times, and you flip the x plus 4 minus 2x. So that's 1 times x plus 4. It's just x plus 4. And in the denominator, 1 times minus 2x. So it's going to be just the same thing, minus 2x. So then that will be the final answer. The x plus 4 over minus 2 minus 2x. So I think, guys, Samira, you have there's a wrong sign. So it's supposed to be, yeah, it's minus. Probably, I mean, another way to write this answer would be like minus, but then parentheses x plus 4, and then over the 2 plus 2x. Okay, but this, if you put minus, you need the parentheses, right? So I mean, it's the same answer. I mean, this is my final answer, but I mean, this is just another way, I mean, to write the answer is this one here with a minus. I mean, because I have minus here, I have a minus here, so you can like, factor out the minus. So we're gonna have like minus and then like parentheses, right? 2 plus 2x. Yeah. Anyway, so is there any question, guys, how I got this x plus 4 minus 2 minus 2x? Just be careful. Yeah, the parentheses, because okay, perfect. So yeah, just be careful with the parentheses, guys. When you subtract, it makes a huge difference if you don't put the, I mean, you get you get the wrong answer if you don't put the parentheses, right? Yeah. Okay, perfect. Well, so that's for, compositional functions. And actually, we are not done yet, because now we're going to try to use graphs. So we're going to use graphs to find this composition of functions. So using graphs. Okay, so let me graph two different functions, f and g. Let's say here's my f. Oops. So here's my f of x. All right, so okay, so let's say have something here, and right here. is 0. And then let's say it goes down here, and then here. And so this is f of x. I can put numbers for you guys. Like I mean, this is like -2. You know, this is like -1, +1, +2. This is +1. You know, this is +2. This is -2, and this is -1. Right. So that's my f of x. Now, now let's graph g of x. This is f of x. Now let's graph g of x. Right, here's my g of x. So we have a point right here. So this is right here, and then we have an empty dot, and then it goes right here, and then up here, right, and then right here. So this is my g of x, and then for your convenience, this is like a -2, -1, you know, 1, 2. This is +1, +2, -2, etc. You know, so these are the graphs of f and g. And now, guys, let's say you want to find. So first, before composition, so let's say just you want to find. You know, let's say f plus g of -2. All right. So let me just remind you how do we find this f plus g of -2? So this is like f plus g of x, right? This is the addition of two functions. So it's supposed to be f of x. My x is -2, so it's f of -2 plus g of x. But my x is -2, so it's g of -2. Right? So then all you have to do is to find, you know, first you have to find f of -2, and then you have to find the g of -2. So for example, f of -2, here's my -2, so f of -2 would be, you know, +1. So this is +1. And the g of -2, so here's my -2, right? My x equals to -2. So then g of -2 would be, you know, you go down here, that corresponds to -2. So g of -2 is -2. All right. So then that's like a +1 plus -2. And so final answer would be -1. Right? So that's for the addition, right? So that's how we find the addition of, so when you add two functions using graphs, right? So now let's say you have a composition. So let's say I have f composed with g of -1. So f composed with g of -1. So again, this -1 is like my x. So this is like f composed with g of x. So it's supposed to be like f of, and then g of x. But my x is -1, so it's g of -1. So what we do first, guys, is to find this number. First, we have to, you know, it's like PEMDAS rule. So we have to find what's inside the parentheses. So inside the parentheses, you see this, you know, g of -1. So I have first to find this number, right? And then I have, I still have an f outside, right? So first I have to find my g of -1. So let's find g of -1. That would be, well, here probably -1 is a bad example because it's undefined. So let me just, instead of -1, let me just use 0, all right? Okay, so here, let's say instead of -1, I'm gonna use 0. Right? So let's say you wanna find first g of 0. So here's my 0, x is 0. G of 0 would be this point, which is -1. So this is actually, this number here is -1, right? But as I said, we still have an f outside the parentheses. So it's like, this is like f of, and inside the parentheses, we said the g of 0 is -1. So inside the parentheses, I have -1. Right? Now, so I still have to evaluate this f, right? So f of -1, that's my g of 0. So f of -1 now, it's actually equal to, so here's my -1, and f of -1 would be -1. So the answer is equal to -1, right?
Wait, Professor, where is it? You said -1 is, we're looking at the F graph, right?
Yeah, f
And
of
then,
-1, yeah, and then
oh, okay, I didn't see you make
yeah,
the
it's
yellow.
it's
Okay.
still -1, yeah.
Okay.
Um,
But wouldn't it, but would, so wouldn't it be -1 times -1?
no, it's not. No, it's not -1 times -1. It's so inside the parentheses here, you have g of 0, right?
Mm-hmm.
And then we said this g of 0 is actually -1.
So what about the, so what does the F, so
Yeah,
the answer for this, we just have to figure out what the F is. So
yeah,
we don't have to multiply or add or like how we did the
yeah.
last
You
time.
have to figure out
Okay.
what's f of -1.
Mm.
Yeah. Uh, of course, here just to remind you guys, if you have this empty dot, this empty dot, it's undefined. I mean, it's excluded, right? So it's undefined. That's why I changed my -1 to 0, because it's just probably it's not a good first example. But so let me just remind you. So this dot means that the point is excluded, right? This is excluded. Okay, so it's undefined. Anyway, guys, so here's a couple of compositions and uh, you know um, um, addition, subtraction, etc. to compute. So please find the following. Let's say you need to find f times g of +1, then f over g of let's say +2. It's +2, right? And then let's say you want to find, let's find f composed with g of -2, right? And then g composed with f of -2, right? And then f composed with f of let's say +2, right? And then you can have also g composed with g of let's see, um, 0, let's say +1, right? Here, let's say this is +1. All right, guys, so please use the graphs here to find these values. So if you need to see the graphs again, yeah, for -1, it's undefined. Yeah, g of, g of -1 is undefined. Yeah, absolutely. Anyway, so if you need to see the graphs, guys, just let me know, all right? So I can move the board up. Uh, Again, guys, this dot here, the dot means multiplication, right? And the circle means composition, right? So it's just two different operations. Yes, sure. I can go back to the graphs. Yeah, that's why I was. Yeah, sure. I can probably erase the the yellow lines here. Probably they're kind of confusing. All right, so oops. Mm-hmm. And here, yeah. So I think this is similar to problem number 3 in the homework, if I'm not if I'm not mistaken. And by the way, guys, there is a limit on the file on the size of the files that I can upload on Blackboard. So that's why I'm using YouTube, to upload my the sessions recordings. Yeah, so it's just because there is a limit on the size, of the file. So I have to use now YouTube. Um, yeah, Lenin, you are saying it's done. Okay, very good. Um, so, okay, so I'm gonna give you 1 or 2 more minutes, and then Kwame, you're saying 1 is -4. So 1 is -4. So let me see. Yes, you're correct. Absolutely. Yeah. Yes. Yeah. Correct, Kwame. First answer is -4. Yes. Number 2, you're saying it's 0. Let's see. Yes. Yeah. Yeah. Correct. Yeah. Absolutely. 0. Number 2. Yeah. What about number 3? Uh, 3 is 1. Let me see. So it's first we have g of -2, which is a -2. Yes, very good. Very good. Excellent, guys. Yes, very good. Yes, excellent. Yeah. And then 0 and then 1. Yes, I think you're correct. Yeah, very good, Kwame Lenin. Yes, I think your answers are correct. So, and number 6, you are saying is 1. Let me see. It's G. G of 1 is 2. Yes, very good. Yeah, very good. Absolutely. Okay, guys, I guess probably are done with the, sorry, with the exercise. So for the first one, as I said, it's a dot, so it's a multiplication, right? So it's supposed to be f of 1 times, it's a multiplication, g of 1. F of 1, so this f of 1, so let's find f of 1 first. So you see f of 1, here's 1, and f of 1 would be then -2. So it's this is -2, right? And then g of 1, here's 1, and g of 1 would be +2. So here, this is +2. So the answer would be, this is a multiplication, right? So it's -2 times +2, which is, of course, -4. So for the first one, the answer should be -4. So now, next, again, guys, please feel free to interrupt me and ask questions if you have any. For f over g of 2, so it's a division, so it's supposed to be like f of 2 over g of 2. So f of 2 is 0, right? So f of 2 is 0. So this is 0 over, and then g of 2 is actually 1. So it's divided by 1 here. So 0 over 1, 0 over any non-zero number is 0. So your final answer must be 0. Remember, guys, if you have 0 in the top, then the answer is 0. If you have 0 in the bottom, then it's undefined. Next, so this is now a composition. It's not multiplication, it's composition. So it's f first, then between parentheses we have g of x, which is x is -2, so it's g of -2. Right, so you see this thing here between the parentheses, the g of -2, right? So I have to find the g of -2, and that will be between the parentheses, and then I have I still have an f outside, right? So first, g of -2 is it's actually +1. Oh, sorry, -2, right? G of -2 is -2, right? You see right here, g of -2, it's -2. So here it's gonna be -2. Right now, it's f of -2. It's not f times -2. It's f of -2. So we have to find f of -2. So we go to the graph of f, and here's -2. And so f of -2 would be +1. So f of -2 is +1. So the answer is +1. This is +1. Any question about how I got this +1? Because this is like the new, this is like the new operation here. So yeah, okay. So there's no question. So good. So let's do the next, g of f of -2. Well, f of -2, if you check the graph, this -2 here, f of -2 inside the parentheses, that's +1. So here I'm going to have +1. And as I said, we still have, there's a g outside. So now it's g of +1. So we need to find g of +1. And you can see, this is +1. So g of +1 is +2. So the answer is +2. So here that will be equal to +2. Right. Next, f of f. Yeah, so we can compose the function with itself. There's no problem. So it's f of 2. So here between parentheses, I have f of 2. So I need to find this f of 2. And again, I have another f outside. So between parentheses, f of 2. So let's find f of 2. F of 2 is, you see here's 2. So then f of 2 is 0. So that's 0 here. And then now I have to find f of 0. Let's find f of 0. F of 0 is again 0. So it's f of 0 is 0. Last one, g. It's g composed with g of 1. So again here, between the parentheses, you see this g of 1 here. So I need to find g of 1, and then I have another g outside. So I'm gonna keep the g outside. So first I have to find g of 1. G of 1 turns out to be, well, it's 2, right? You see here, this is 1 here. And so g of 1, it's 2. So that's, so here between parentheses, I have 2. And now I have to find, there's a g outside. So I have to find g of 2. Again, I'm going to use the graph of g. So g of 2, it's, here's 2. G of 2 would be, +1, right? This is +1. So the answer would be +1. So g of 2 is +1. And that would be a fine answer. Right? So, any question, guys, how I got these numbers or any of them? All right, so there's no question. Good. Very good. So that's how we use graphs, right, to find this composition of functions. So next, guys, this composition of functions is like an operation, right? Like
Professor.
yes, yes.
So the last one, g of 1, isn't that undefined? That's -1.
-1. That's -1.
Oh, that's -1. Oh, yeah, I did.
Sure. Okay, so yeah, I was saying, I mean, this composition is like an operation, right? And for algebraic operations like addition or subtraction or multiplication or division, remember we try to find the domain of those operations. Like we said, the domain of f plus g, f minus g, f times g would be the domain or the intersection domain or the common domain, right? Now, so the question now is, what about the domain of f composed with g? So now the goal is to find the domain of f composed with g of x. Remember, guys, we had a theorem for f plus g, f minus g, f times g, or f divided by g. We can use the common or the intersection domain of f and g, right? Now, so this is a different operation as a composition. So the domain of f composed with g is going to be a little bit different. So actually, there are mainly 3 steps. So if you want to find the domain of f of composed with g, so there are 3 steps. So in step 1, in the first step, you need to find the domain of the second function, which is g. So in step 1, you need to find domain of the second function of g of x, the second function. So if you have like G composed with F, right? If you have like G composed with F, so F would be the second function, then in this first step, you need to find the domain of F, right? Because that will be the second function. But here we are talking about, F composed with G. So my G is the second function. So you need to find the domain of the second function. So the second function here in the first step, right? In the second step, step number 2, so now you have to evaluate f of g of x, evaluate and simplify f of g of x, and find its the corresponding domain. So find its domain. Right. Then in the last step, step 3, we find the answer. So domain of f composed with g. So domain of f composed with g is the intersection of the domain of the first step, the domain of g, of the domains in step 1 and step 2. So step 1, that's the domain of g, and step 2, that's the domain of when you simplify f of g of x. Right. So okay, so for example, okay, let's do an example so we can see how it works. All right, so here's an example. Right, so let's say my f of x is it's let's say 1 over x minus 2, right? And then g of x is let's say let's say x minus 1 over x plus 1, right? So that's my f, that's my g. Now the question is to find, let's say I want to find domain of f composed with g, right? So what you do, guys, first step, we said step 1, I mean, here f composed with g, so g is the second function, right? My g is the second function. So in the step 1, I'm gonna find domain of g. So step 1, step 1, so first I'm gonna need domain of g of x. So g of x is x minus 1 over x plus 1. So now, guys, let me just remind you, how do we find domain of functions? All right, so we said there are basically two rules. If you have a fraction, then you have to solve the denominator equal to 0, right? That's the first rule. So you have to solve the denominator equal to 0, and you have to exclude the values that you get from the domain. Now, if you have a square root, then you have to solve. So wherever you have under the square root, so let's say here you have something here under the square root, right? So then you have to solve what's in the expression under the square root larger or equal to 0, right? So that's like the two main rules here. So this is the first rule, and this is like the second rule. Anyway, so here's my function g. My function g, I mean, there's no square root in my function g, okay? So that's the good news. However, of course, my function g is a fraction. So this is a fraction, right? This is a fraction. And so we have to solve the bottom equal to 0. So it's a fraction, so we have to solve the bottom equal to 0. So the bottom is x plus 1 equal to 0. So then my x, if you subtract 1, of course, so then my x would be -1, right? So the domain would be any real number except the -1. So I have to exclude the -1. So this -1 to be excluded, right? So the domain of G, so this is the D subscript G, domain of G. It's any real number except -1. So I'm gonna use parentheses to exclude -1. Union, so this is union, of course, -1 positive affinity. So that's the domain of G. That's the first step. You need to find the domain of the second function, which is G of x. Now, sorry, that's the first step. Now, the second step, step number 2, we said in the step number 2, we have to simplify. Step number 2, we have to simplify and find domain of f of g of x. Right, that's my function, right? F of g of x. So let's compute this thing here. F of g of x. My f of x, f of x, we said it's 1 over x minus 2. So it's 1 over x minus 2. Right now, I have to compute f of g of x. Right, so here's an x. There's an x in here in the denominator of f. So f of g of x is going to be 1 over, so that'll be my g here, g of x, and then of course minus 2. So that's 1 over, so g of x is x minus 1 over, probably I'm going to use the blue. So this is x minus 1 over x plus 1, x minus 1 over x plus 1. Right, and then there's a minus 2. There's a minus 2. Right, so we need to simplify this thing here. As I said, here we have, you have fractions. So I have 2. I'm gonna make it as a fraction, so I'm gonna divide by 1. I have 1 here in the top, so I'm gonna divide by 1. So now everything looks like a fraction, and now I can do. First, I have. In the denominator, I have a subtraction, right? So we're gonna need a common denominator. I'm gonna need to multiply here by, so the denominator is x plus 1, right? Common denominator is gonna be x plus 1. So here's times x plus 1 times x plus 1, all right? So it's equal to, so we're gonna have 1 over 1, and then it's x minus 1 over x plus 1 minus 2 times x plus 1 over, over 1 times x plus 1. So it's x plus 1, right? So it's going to be equal to, so it's 1 over 1. And in the denominator, so we have a subtraction of fractions. So I'm going to subtract fractions. So it's x minus 1 minus 2 over x plus 1. And then we keep, of course, the common denominator, which is x plus 1. All right, so let's see. So that will be equal to, so it's 1 over 1 in the top. And then we have, in the bottom, we have x minus 1 minus 2x. And then minus 2 times positive 1, that's negative 2, so minus 2 here. And then, of course, there's an x plus 1 in the denominator. So it's 1 over 1, and then x, so let's see how many x's here. X minus 2x, that's minus x. So you're going to have minus x. And then minus 1 minus 2. So you see here, minus 1 minus 2. So that's minus 3. Right? So this is minus 3 here. And then, of course, again, the x plus 1 in the denominator. Okay, so I'm done with the subtraction of fractions in the denominator. Now I can divide, I have two fractions as usual. So here we flip this one here, so it's going to be like, 1/1 times, and then we flip the one in the fraction in the denominator. So it's x plus 1 over minus x minus 3. Right, so you multiply, so it's just x plus 1 in the top because it's multiplied by 1, so it's going to be the same thing, and same thing in the denominator, which is minus x minus 3. Right, so that's f of g of x after simplification. So that's like the f of g of x. Now you're done. I mean, there's nothing else you can do here. So now I have to find the domain of this thing here. All right, so that's so I have to define the domain of this. So the domain, again, well, this is, it's a fraction again, right? There's no square root, it's just a fraction. And when we have a fraction, we have to solve the denominator equal to 0, right? So we have to solve here, so I have to solve denominator equal to 0. So that's minus x minus 3 equal to 0. You can add plus x both sides, for example. So that would be negative 3 equal to positive x, right? So my x is equal to negative 3. So domain here in this the second step would be any number except this negative 3, right? So here domain would be any, so domain would be any number except negative 3. So it's like negative infinity to negative 3 excluded, union with negative 3 positive infinity. All right, so that's for domain. This is for the second step. So remember, guys, we did the first step. First step was, find the domain of the g, because that's the second function. Okay, we said it's negative infinity, negative 1, excluded, negative 1, positive infinity, right? And now in the second step, you simplify this f of g of x. We got this fraction here, x plus 1 over minus x minus 3. So then we said you have to find the domain of this fraction here. So now find the answer, domain of f of g of x. So we need to take the intersection. So this is step 3. So in the step 3, you have to take the intersection of the domains in the first step and the second step. So here you need to find the intersection, or the intersection of the domains in the first step and the second step. Intersection of the domains in the step 1 and the step 2. In step 1 and step 2. Right? Step 1. Okay, so in step 1, we had domain of G. We said it's, so step 1, we said domain of G. We said any number except, where's domain of G? We said, yeah, here, any number except negative 1, right? So we have, in the step 1, we have, so we have negative infinity, negative 1, union with negative 1, exclude, of course, positive infinity. And the step 2, we got any number except negative 3. So it's negative 3 here, union with negative 3 and positive infinity. So now what I'm going to do, I'm going to take the intersection of these two domains, right? So, so here's my number line. I'm going to need negative 1, and I'm going to need negative 3. So here's my negative 3, here's my negative 1, here's my negative infinity, positive infinity. So domain in the first step, domain of G, we said it's any number except negative 1. So any number except negative 1. Use parentheses to exclude negative 1. And then from the second step, we said it's any number except negative 3. So here, I'm going to use the green for the second step. So I'm going to exclude the negative 3. All right. Well, so what will be the intersection here? What will be the domain, which is at the same time green and red? Well, I mean, here everything looks like green and red at the same time, except, of course, there's the -3 and -1 because they are excluded, right? I mean, -1 is excluded from the domain of G. So here everything it's common except the -3 and the -1, right? So final answer, domain of F composed with G is, so negative infinity to -3 excluded, right? And then union with -3 to -1 union, and then from -1 to positive infinity, and then from -1 to positive infinity, right? So that would be the domain of F composed with G, right? So again, the steps: first, domain of the second function, which is here domain of G, right? Because it's F of a composed with G. Second step, you have to simplify this F of G of X. You get your answer, then you find the domain. Right here, my answer was this fraction x plus 1 over minus x minus 3, right? And then I got the domain. And then the final step, step 3, you have to take the intersection of the domains in the first and the second step. Is there any question, guys, about this example?
Can you scroll all the way down?
Yeah, all the way down, sure. Right. So you see here in step 1, I got negative infinity, -1, union -1, positive infinity. Step 2, I got any number except -3, right? And then I take the intersection. Okay, so if there's no question, guys, so let me give you a similar problem. So here's an exercise. Here's exercise. Right? So let's have square roots here. Okay, so let's say f of x. Okay, f of x is, let's say it's x plus 1 over x minus 4, right? And g of x, so let's say it's square root. All right, it's the square root of 25 minus x, right? And let's say minus 1. The minus 1 is outside the square root, right? So what you need to do, guys, you need to find domain of let's say f, just f composed with g of x, right? So a domain of f composed with g. So yeah, so please, guys, I mean, follow the same steps, right? Well, difference here with the example, I mean, my g here is a square root, right? Just be careful. I mean, square root, we said the domain, you need to, take the what's under the square root, larger or equal to 0. But anyway, so yeah, so please follow the same steps and try to find this domain of f composed with g of x. So I guess I mean we are almost done with this section 1.7. So on Wednesday we're gonna start a new section, section 1.8. It's about the inverse of functions, and then it's actually kind of a short section. So then we can probably start section 2.2, right? And that will be the material for for the first test. Anyway, and then of course. Um, yeah, and as I said, the next Monday it's a holiday, so we're gonna meet on. Of course, we're gonna meet on Wednesday as usual. Yeah, so please don't forget your homework. It's due this homework number homework number 4 is due this Wednesday. Tomorrow I will send you the grades. I mean, or you can find your grades on Blackboard. All right, for homework number 3. And yeah, and as I said, I will post a review sheet next week. Um, uh, for the test. Again, so the test is on October 21st, and we're gonna have a review on October 19th. Mamadou, you're saying I didn't see my email. You mean about the grade of the homework grade of the homework?
Yeah.
Homework number 3.
And you told me that I should call the school.
Oh no, you're talking about the tutor.com.
Yeah.
Oh, yeah. I mean, I think I CC'd you in an email. Did the guys from the technology center did they contact you or something?
No, no,
No one.
no one. Yeah.
This is weird. But did you see my email? I mean, when I CC'd you and I was asking the guys from uh, the Center of Technology to try to fix your the problem with the tutor.com. You didn't get that email?
No, maybe I think you confused me with another student.
Oh, okay. Okay, probably yeah, I did.
Yeah, I think so.
Yeah, okay. Oh, I see.
Yeah.
All right.
But about the homework number 2,
Number
I
2.
sent you an email.
Oh yeah. I got your homework number 2. Yes. Yeah. Because I was supposed to grade it with the homework number 3. Yes. Yeah, but tomorrow I will send you the grade for homework number 2 for sure.
Okay.
Yeah.
Thank you.
Yeah, sure, no problem. Yeah, again, guys, I mean, you need to take advantage of my office hours. So again, I'm available on Monday and Wednesday. I mean, from 4 to 5. Okay, so I'm gonna be connected. I mean, our Zoom link. So that's from Monday and Wednesday from 4 to 5. And also, don't forget to, our department, the math department, offer online tutoring, right? And so you can find the links, all the information's on Blackboard. Okay, so if you have a trouble with the homework or with the review sheet, you can always take advantage of this the tutoring. All right. It's online. I mean, it's free, and it's. It's a 24/7 service. I mean, if I mean the tutoring offered by the department, I think it's on. It goes from like Monday to Friday. Like I think it's from 10 a.m. to 4 p.m. But after 4 p.m., you can use this tutor.com. Okay, but I think you in the whole semester you only have 10 hours. For this tutor.com. But again, it's when it's you can use when outside the department tutoring hours, right? So yeah, but anyway, so please, take advantage of the tutoring. I mean, it's free and it's available all the time. So you can find all different informations about the tutoring on Blackboard. Anyway, so any question, guys, about this exercise? Um, any guess for the answer? What will be the domain of this F composed with G? Um, so Muhammad, you're saying negative infinity? Yes, that's step one. Yes, yes, correct, Muhammad. Samira, is that like the final answer? I think, yeah. Okay. Let me see. Actually, you are correct, except that probably you have to include the 25. So you have to use the bracket with 25. Yes. Yes. So yeah, yeah. Then that's the correct answer. Yes, absolutely. Yeah. Sorry, guys. Yes. Oops. Yes, very good, Samira. Yes. So anyone else has a trouble or a question or okay. Well, probably I guess I don't know if you are done with the exercise. Well, I can give you 1 or 2 more minutes. All right, guys. I guess you're done with the exercise. Well, at least I can probably start with the step one. So we're gonna find this domain of f composed of g. So first we start the domain of the second function, the domain of g. So step one, we need to find the domain of g. All right, so my g of x is square root of 25 minus x, and there's minus 1 outside the square root. So for domain of g, guys, there's no fraction, obviously, right? But then we do have a square root, right? Now, as I said, the square root, you have to solve what's under the square root larger or equal to 0. So under the square root, I have 25 minus x. All right, so I don't include the negative minus 1. So all I have to solve is the 25 minus x larger or equal to 0. Okay, that's what's under the square root, right? That's the 25 minus x. All right, so let's solve for x. So you can add here plus x, then plus x in here. So there will be 25 larger or equal to x, right? So 25 larger or equal to x, it means that x is less than 25, right? So x is less or equal to 25, right? So this is, again, so this is here, this is less, all right? Less or equal to 25, right? I mean, 25 is larger than x, it means that x is less than 25. So, I mean, for the domain of g, let's say this is 25, x is any number less than 25. So this is, x is less than 25. So domain of g would be 25 is included. So domain of g, so d subscript g, it's negative infinity to 25, and 25 is included, all right, because x can be equal to 25. Right? So that's for the domain of g. Now, second step, we said we have to evaluate. So step 2, we have to simplify, this f of g of x, right? So again, I mean, f of x, it's x plus 1 over x minus 4. So x plus 1 over x minus 4. And now I want to compute f of g of x. So you see there's an x in the top and there's an x in the bottom. So that x would be now g of x. So here's going to be g of x plus 1. And we're going to have a g of x in the denominator. And there is a plus 4. Right? So that'll be equal to.
Wait, put minus 4 on top though.
Minus.
Minus in the top.
Yeah.
Oh, minus 4. Sorry, you're saying minus 4. Yeah, thank you, guys. Yeah, thank you, Lenny. Yeah, thank you. Sorry. Yeah, it's minus 4. Thank you. That's important, actually. Yeah, that's very important. So g of x is where is it? G of x. Yeah, it's the square root of 25 minus x minus 1. So so it's square root of 25 minus x minus. Sorry, I forgot. So yeah, minus 1. Minus 1 here outside the parentheses. Right? That's my g of x. This is my g, right? This is my g of x. And then there's a plus 1, guys, right? This is here, there's a plus 1. So I'm going to need a plus 1 here, right? Over, again, so g of x, 25 minus x minus 1, right? And then there is this minus 4. So here's my minus 4. So, okay, so let's simplify this thing here. So this is now, so f g of x So there's this square root of 25 minus x. There's minus 1 plus 1, so they cancel out here, right? So it's just the square root of 25 minus x in the top, and in the bottom, it's square root of 25 minus x, right? And then there's minus 1 minus 4, so that'll be minus 5. Right, so it's actually square root of 25 minus x over square root of 25 minus x, and then there's minus 5. So again, guys, here, be careful. Like in the denominator, you cannot really subtract the 5 from the 25, right? Because the 25 is under the square root. So you cannot really mix, the terms under square root with the one outside the square root, right? So you cannot subtract the 5 from the 25. You cannot cancel out the square root of 25 minus x because in the denominator, it's not a multiplication, it's a subtraction, right? So you cannot cancel out the square root of 25 minus x. And actually, that's all we can do here, right? There's no more simplification here. As I said, you cannot cancel out the square root of 25 minus x because it's a subtraction in the denominator. It's not a multiplication, right? So that's actually the answer. Now, you need to find, the domain of this f of g of x, right? Well, first, it's a fraction, right? You have a fraction here. It's a division here. This is a fraction. Okay, and we said when we have a fraction, you have to make sure that the denominator, the bottom, is not 0. So we have to solve. The bottom, because it's a fraction. We have to solve the bottom is equal to 0. Right. So the bottom is the denominator is square root of. So we have. So we have to solve square root of 25 minus x minus 5. Okay, so you have to include the minus 5 because it's in the denominator. So the whole denominator equal to 0, right? So it's equal to 0, right? That's what we have to solve. Right? Sorry, guys, I'm going over time, but okay, let me just go quickly. So here's plus 5, so it's square root of 25 minus x equal to positive 5. So then, and then get rid of the square root. So you apply square here. So it's 25 minus x equal to 25. You can subtract 25 both sides, right? So it's 0 minus x, so it's negative x equal to 0. Then you can divide by negative 1 to make it positive x. So it's 0 over negative 1, so that's 0. So it's actually x is equal to 0. So this is x equal to 0, so this is to be excluded, right? So, and of course, so that's because we have a fraction, right? So we had to solve this bottom equal to 0. So I got this x equal to 0. So I have to exclude this x equal to 0. And you see, so here's my number line, here's 0. And you have to exclude this x equal to 0, right? So it's, exclude this 0, right? So here, then in the step 3, you take the domain of G. So domain of G, we said it's negative infinity. Domain of G, sorry. So domain of G, we said it's negative infinity, positive 25. Right, 25 is included. So here I have to take the domain of the step 2, which is with the 0 excluded. So here's the domain of G. All right, so I'm gonna need 25 here. Let's say this is 25, and so the domain of G would be from negative infinity to 25. 25 is included. right? So that's so the blue domain is the domain of G. That's from the first step, right? And so what will be the intersection now between the domain of G, I mean the blue domain and the green domain? So the green domain is any number except 0. So the intersection would be, so the domain which is blue and green at the same time, so it's going to be this domain with the 0 excluded, right? Because we had to exclude 0, and then it goes all the way to 25. So the answer here, guys, final answer should be, so domain of f composed with G, of f composed with G of x is, so it's going to be actually negative infinity, 0, 0 excluded, right? Because we had to exclude 0, union, again, 0 excluded, 225 included, right? So again, that's the intersection, intersection of the domain of G with the domain and the second step. Okay, guys, I'm sorry, I went over time, so that's the final answer here.
Can you scroll down, please? I can't see answer domain.
Oh yeah, sure. Here. Yeah, sorry, Glenn. Yeah, so that's it for today, and I guess I will see you on Wednesday. And yeah, so thank you, guys. I'm here. I mean, if you have any questions, of course. But otherwise, I will see you on Wednesday.
All right, thank you, Professor. I'm able to do the other parts of my homework.
Thank you, guys. Appreciate it. Thanks. I will see you on Wednesday. Thanks. Take care and stay safe, of course.